Hey there, YouTubers. Welcome to another fun-filled, fabulous episode of Afternoon Garage. So as promised, I'm going to do the wiring. I'm going to do the wiring within the channel itself. It's going to be a little complicated because, as I said last week, there's data lines running all over the place in this car, and we got to make sure to make that as simple as possible. At the same time, we have a parallel loading issue I'm kind of worried about with this small little tiny LED controller being able to support everything I got going on in this car. So anyway, without any further delay, let's get to the bench. Okay, let's talk a little bit about these devices and how they work. So they're individual on a strip. The strip can be cut at any point. This right here is an IP30, meaning it just has maybe a clear coat over it called a conformal coat. And that will need to be removed if you're going to go solder these. These are not bare copper. Here's internally what the IC looks like. So you have your red, green, and blue LEDs in there, and you have an IC in there that interprets the data and turns the red, green, or blue LED on at a desired intensity and develops a color. So the pinout of the 2812, a data in, a data out, plus 5 volts and a ground. One thing to remember, the 2812Bs, as far as I've ever seen, are always going to be 5 volts, so you're going to need a voltage regulator or some type of a DC to DC converter. This is typically how the circuit is set up on the strip itself, where you have your data line going in the input and then an output going to the next device and to the next device. This is what in the Arduino world we call bit banging. Every LED is going to be addressable in the chain. This controller can control 2048 LEDs. I'm not really sure what that means because I'll show you here in a minute that they only drive 16 at a time and then the cycle repeats. So theoretically you would think that this LED, I assume it's just a PIC, could drive an infinite amount of LEDs. Anyway, let's hook it up and do some probing. All right, what we have here is fairly simple. I choose to use 12-volt batteries instead of power supplies. They're really easy to haul and test things with. And then we have a DC to DC converter. As I showed before, this is a 5 volts at 10 amps. So you're probably going to draw somewhere in the neighborhood. Wow, this is also takes 12 or 24 volts in. So what you have is you have the power supply in connecting to the battery, and you get 5 volts at 10 amps coming out. We're going directly into the controller, and we're going right into the light strip. So plus to plus, minus to minus. Don't short anything out. And let's see if we can get something happening. There we go. I like these colors. We can see here that after this LED, the cycle was repeating. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, and the cycle repeats. Okay, this color is a little bit easier to see on the scope here what's going on. So what we have is we have 5 volts going to this, and then I have a probe on the data line so we can see the information coming out of there. You can see all the different data for each IC, and you can see the amplitude is also changing. And you can see these are the individual packets that are addressing the LEDs themselves. If you slow this way down, you can start to see there's the reset. You can see the amplitude is changing. So it's very interesting. We don't need to know too much what's going on in there, but I have a concern about where to put the LEDs, and let me tell you how that's going to work. There's an LED strip that's under here, 3 under here, 1 in the front. The thing is if you know how these strips work, the way I described them, there's a data path. And so it's a serial path that travels from one LED to the other. So how these things are supposed to be connected is there's a data stream on the input, and it runs from one LED, gets to the end, and then dumps off the end. Well, the data line has to go somewhere, and then that would go to the next LED strip. What I don't want to have happen is to have wires all over the car and string the in to the out. Let's do a little research and see how much we can load that down. If we have 3 or 4 strips that we know activate independently and are working correctly, then I don't see a problem with just wiring all the outputs together. Now, one thing to note about LED strips, now that we know that it's a data stream, there's definitely going to be a direction, as we talked about before. That indicates the direction of the data path. You want to take your razor blade just at where those markings are that tell you 5 volts, data, and ground, and you want to cut it right there. Slice back and forth until you can feel a difference. That means you're through the silicone. Try not to cut any more than that. Allow your blade to sit flat. This is a lot of things to remember. If you do this wrong, you will cut right through it. Don't try to cut it this way. Always make your cuts this way and then kind of break it off like that. Okay, this is the wire I was talking about. This is 20 gauge. One thing that's important is you want to make sure you can see that this isn't flat. Get a nice flat cut on it. And you also only want to strip off probably not even 1/8 of an inch.
Next level. Next level.
Okay, so here what I've done is I have added this, which is, these are the two little 8-inch ones that are going to fit in the back. So these are connected up, and you can also see that these start to kind of dim out a little bit. So we definitely want to keep that wire gauge up, keep it above. I think a 20 will handle 10 amps. Here's the piece that we made for the rear. And so then we have the data input going in here, going through the LEDs all the way to the end of the chain to where it picks up, goes through the wire, and then we'll illuminate these LEDs. On this end, we're going to have to tie these data lines together.
Next level.
Okay, the next thing we want to do is we want to cut these lenses. I've chosen the diffuse lens. So you have two different choices for the ends. You have this one here, which is a solid just for the end, and then you have this. This is another one they give you. This hole simply isn't big enough. I end up having to trim these either like that, or sometimes I can elongate the hole and then I'll actually slide it on here before I solder it. That's another method you can use.
Next level. Next level.
Remember, test as you go along. But don't look at it too long. You got a job to do. Here are the three pieces for the front. We want to have it go forward and meet at the middle. Start out with the data path going that way. So connecting the power and the data lines will be simple. We need to inject the data back here rather than there, and then I'll get our direction going towards the front of the vehicle. This distance in here is 5 inches, and we can pretty much hook it up, and then right at the center we're gonna have it stop right in the center where the two arrows are going to be coming in to each other. So let's wire it up.
Next level.
Hours later.
So now you know how we got to this point right here. That was quite a lot of work, huh? Little bit. But you know what? I think it's gonna work really good. So next week what I'm gonna do is I'm gonna be actually installing this thing, doing a little wiring on the inside of the car. Another thing I really don't like about the DeLoreans is the center console switches. They're kind of, well, hokey pokey. I don't know how else to put it. It's kind of an afterthought. I don't really think they really thought it through very much, and they kind of get off center. It's one of the things, if you look at any of these cars at the center console switches, it just doesn't look right. So I'm gonna machine a plate for that, kind of tie that all into the exterior wiring, and we'll get to that next week. Until then, stay safe.